Welcome to Science Manthan. Today we are exploring the incredible, never-ending journey of water as it transforms and travels across our entire planet in this explainer. We're going to take a closer look at a process that is happening literally all around us, every single day, often completely unnoticed. Okay, let's dive into this agenda by tracing a single water drop's journey. We'll be covering 1. The magic of condensation, 2. Journey to the clouds, 3. When clouds get heavy, 4. The endless water cycle, and 5. The complete journey recap.
Let's start with Section 1, the magic of condensation.
So, picture this scenario for a second. If you leave a freezing cold glass of ice water on a table for just a little while, you'll soon notice these mysterious tiny water droplets popping up on the outside of the glass. Now, where exactly do they come from? The glass certainly isn't leaking, right? Well, the answer actually lies in the surrounding air, which is completely packed with invisible water vapor. The crucial point here is that when the invisible water vapor in the surrounding air hits that freezing cold surface of your glass, it undergoes a rapid phase change. It cools down and transforms from a gas right back into tiny liquid water droplets. This fundamental thermodynamic process is what we call condensation. This simple transformation, water vapor turning back into liquid water, is condensation in a nutshell. And what's super cool is that this doesn't just happen to your summer drinks. It beautifully explains how morning dew forms on cool surfaces like grass or your car windshield overnight. The ambient moisture in the air simply meets a cooler surface, and bam, liquid droplets are left behind as the temperature drops. Moving right along to Section 2, Journey to the Clouds. Before we really get into cloud formation, you might be pondering a perfectly logical question. How exactly does the evaporated water vapor from oceans, lakes, rivers, and even the soil travel all the way upward into the sky? Like, what force is pushing it up there? The answer is wonderfully simple, actually, and it's rooted in a core principle of physics. Water vapor is lighter and less dense than the regular air around it. This means that as liquid water turns into a vapor, through heat and evaporation, it naturally floats upward into the atmosphere. It just continues its ascent, riding those thermal currents until it eventually hits much cooler atmospheric conditions higher up in the troposphere. Think of it as an ongoing, continuous sequence of events. First, you have surface water absorbing thermal energy. This water undergoes evaporation to become water vapor. Because it's less dense, that moist air rises, encounters those cooling temperatures, and undergoes our old friend, condensation. Those invisible vapor molecules turn into extremely small liquid water droplets, which then gather together in massive, staggering numbers to form the visible clouds we see drifting across the sky. And you don't even need a hot air balloon to see how this atmospheric science works. You can visualize this whole thing simply by using the bottle model. By taking a closed plastic bottle with just a little water inside, you can squeeze and release it to mimic the rapid pressure and temperature changes that happen up in the atmosphere. Under the right conditions, you'll actually see tiny droplets coalesce to form a cloudy appearance right inside the bottle. It's a perfect miniature demonstration of how water vapor, combined with cooling and pressure shifts, equals condensation. All right, on to Section 3, when clouds get heavy. Inside those puffy clouds floating above us, things are incredibly active. It's kind of like a giant bumper car arena up there. These tiny water particles are constantly interacting, bumping into each other and combining. As they merge, some of these droplets become larger and significantly heavier. Eventually, they get so heavy that the upward atmospheric drafts literally can't support their mass anymore, and gravity steps in to pull them downward. When gravity takes over, this water returns to Earth. Now, while most of these heavy particles fall directed as rain, which, is just heavy liquid droplets, different atmospheric temperatures can completely change the outcome. If the surrounding air is cool enough, the water will freeze and fall as solid precipitation instead, like snow or hail. But whether it's liquid or solid, it is all driven by that initial thermodynamic cycle of evaporation and condensation. Let's jump to Section 4, the endless water cycle. Now that the water has returned to Earth's surface, let's zoom out to look at the macro level of what's really going on here. This entire never-ending journey of water constantly moving between the vast oceans, the open sky, and the land is known as the water cycle. It's truly one of the most fundamental planetary systems keeping our world alive, ensuring that water is continuously transported and recycled across the globe in all its different physical states. Because it is a continuous, closed-loop system, there was actually no single starting or ending point to this natural journey. Evaporation leads to water vapor, which undergoes cooling and condensation to form clouds. This naturally leads to precipitation, which results in surface collection, which, of course, just provides the vital liquid water for evaporation to happen all over again. Finally, Section 5, the complete journey recap. To summarize this explainer perfectly, just remember the core loop. Thermal heat drives evaporation, sending liquid up as a vapor. Atmospheric cooling causes condensation, turning that vapor back into liquid. Those droplets gather to form clouds. When they get too heavy, precipitation brings the water back down. And finally, collection gathers that water in our oceans, lakes, and underground aquifers, completely resetting the board so the entire cycle can repeat continuously. I want to leave you with a completely fascinating thought. Since this continuous cycle means water has been circulating between the Earth and the sky forever, essentially recycling the exact same water molecules for billions of years, how old is the water you're drinking today? Take a moment to think about that. And hey, please like, subscribe, and share for such more science-related videos. Drop your comments and queries in the comment section. We will catch you in next one.